Hi, everyone. Welcome to a brand new episode of the Clear to Send podcast. We have a special episode here for you today. We are bringing on Arista Networks to talk about Wi-Fi and their platform. So we brought on a couple of guests from Arista. We have Metka Dragos here with us and also Robert Ferruolo. Welcome to the show, guys.
Oh, thanks for having us.
Thank you. Thank you for having us.
Yeah, we're really interested to know what you guys have in regards to the Wi-Fi and the different features that everyone can utilize when it comes to configuration, troubleshooting, reporting, and all of that. So in this episode, we're going to talk about an overview of Arista, where we'll also have follow-up episodes. So we're going to kind of go through the whole thing kind of all in once. But before we get to that, why don't you guys introduce yourselves? Starting with you, Metka.
Yeah, so Metka, many people in the industry probably know me. I was a trainer, so I met a lot of people. I'm CWNE number 23, many years in this Wi-Fi industry. And when it comes to Arista, people don't necessarily think Wi-Fi as much as data center and the other ultra cool stuff that Arista is doing. So I think it's very important that we remind the world that Arista also has very awesome Wi-Fi. And Robert and I will try to put some light on that part of Arista offerings.
All right. Thanks, Metka. Yeah, so my name is Robert Ferruolo. I'm a solutions architect / TME. I've been in Wi-Fi, well, I started in the early 2000s and been with the Arista Wi-Fi solution from 2014, early 2014, back in the day when we were called Airtight before the Mojo rebrand. And so I've seen the platform really evolve greatly since the time I've been with the team here, and looking forward to talking more about what we have to offer here. And thanks for having us again.
Of course. And we also have our co-host here, Francois. How are you doing, Francois?
All right, I'm good. Thank you. Yeah, I'm good. I'm happy to have Arista. We don't really hear about them when it comes to Wi-Fi. We'll always hear about the other vendors. But sometimes we hear people in the field saying, it's too bad we don't hear about Arista more often. They have good stuff. So I'm happy we can have you guys on the show today to kind of put some light on those features, I guess.
Yeah, we do actually have a few comments sometimes on our Clear to Send Slack where someone goes, has anyone ever used Arista Wi-Fi? And that actually came up recently, and I told them, like, hey, if you have any questions, let us know, because we're gonna have them on an episode. And so they were happy to hear about that, because Arista, we do know from the data center side, right? A lot of switching from Arista, and now that Arista is being part of Mobility Field Day, I think you guys are trying to get your name out there, and people are wondering why Arista, right? Well, what do you guys offer, and what's different about Arista? So maybe we can take it off from there.
Yeah, I guess I can start with that. Most of you will probably know that Airtight was a WIPS company only, WIPS overlay. And that's all we did for a long time. For probably half of our lifetime, we're just a WIPS overlay company. And so we still have a lot of deployments where we're a WIPS overlay. So you'll have other competitors start doing the Wi-Fi, and then we'll be working with that solution as an overlay to provide WIPS threat detection and prevention, automatic. And that's the key, automatic. So I mentioned that, I joined, Airtight back in 2014. And so they already had an automatic WIPS solution that was solid, right? Self-driving in terms of threat detection and threat prevention. And then shortly after, I'd say maybe 2 years after joining, we decided that we were going to take the company in a direction of having automatic self-driving in terms of access. Now, access was already there. I mean, the beginning of access was there. We already had turned on wireless LAN capabilities, but it was rudimentary. And then about 7 years ago, we said we're going to take the same approach to automation, in terms of threat detection and threat prevention, and we were going to use that same approach for self-driving network in terms of wireless LAN optimization and fault detection and remediation, etc. And so that's a journey we started on about 6-7 years ago. And so that, I think, is what differentiates us. I mean, if you think about what, if you look at a lot of competitors in terms of their WIP solutions, most of them don't recommend turning on automatic prevention. And the reason why they don't is because they're not sure. They're not confident that you're going to just deal with the threat and not interfere with the neighbor's network. And so there's that level of confidence. And so we, again, using that same deterministic approach that we took on the Wi-Fi threat detection and prevention, we're taking that same deterministic approach in terms of network optimization and fault recognition and remediation, et cetera. So that's the journey we're on. I think that's what differentiates us. We had a head start on that. And you'll see a lot of competitors now are starting to implement some of those same root cause analysis, automatic root cause analysis, automatic remediation. But some of the things we'll talk about today, we've had in our product for 5 years, 6 years now.
I know I unmute myself, so I'm supposed to talk, right? I unmute myself and I was like, what did I want to say? So anyway, yeah, I wanted to, kind of going back on what Robert was saying, you guys have a very strong security background with Airtight and Mojo after that. And then Arista purchased Mojo Networks, correct me if I'm wrong, right? To include that solution into the Arista portfolio, I guess. Can you tell us like when that acquisition happened and what it meant for, I guess, the wireless solution and
Sure.
how you guys are working on it today?
Right. Yeah. So that was in 2018, August of 2018, when that acquisition happened, and it was the first acquisition too for Arista, and so it was definitely a learning experience for both entities, and it took a little while for us to get our groove, so to speak, but now we definitely are on on that path, and the two we're one company now. We're not a subsidiary. We're it's Arista Wi-Fi. It's no longer Mojo Wi-Fi, and a lot of the same great philosophies in terms of quality that you saw on the Arista side. Now we had solid quality on the Mojo side, but yet for some of you probably are familiar with it's almost like a religion in terms of quality first on the Arista side. And I, for one, I remember thinking back in the going way back, thinking, wow, I wish there was a Lexus for networking, and because I was a field guy, so I was the guy that was out on site for the first 20 years of my career, at 3, 4, 5 in the morning, night after night, or morning after morning rather, because of quality issues. And I won't mention which companies I was working for at the time, but that's just the industry in general, right? And I was thinking, wow, if we only had a Lexus of networking. And what I mean by that is that where they really prioritize quality. And that is definitely the Arista philosophy. It starts, with Ken Duda, and that's his philosophy. And that has definitely pervaded, and it's come into the Mojo side. We're not there. We're not at the same, level that the switching side is at, but that's something we're definitely working towards. So that's exciting, because now, if there was, a Lexus of networking, you could say probably Arista approaches that because of the way they prioritize quality. So that's one of the big things that I see happening, which is, big plus for sure.
Awesome. And for those listening to the podcast, we also have a video recording of this because we're going to be sharing some of the platform over video as well. So if you go to clear2send.net/276, you'll find that recording on our YouTube channel. One thing that I see on your screen there, Robert, is it says Cognitive Wi-Fi. Can you explain to people what Cognitive Wi-Fi means? Yeah,
that goes back to what I was saying about self-driving and being a field person as long as I was. I mean, it's you appreciate the extra help. So just having a system that's able to do things automatically, whether it's automatic provisioning, automatic root cause analysis, automatic network optimization. That's really what we mean by cognitive, the ability for the machine to make decisions based on various inputs, based on KPIs, and then being able to, or pattern recognition. That's really what we mean by cognitive. So you can think of it as just having a helping hand. The machine is assisting, right? It's self-driving to a certain extent. Now, admittedly, we have a long way to go. On the WIP side, on the security side, it's truly self-driving. On the network optimization side and automatic root cause analysis and remediation, we're down that, we started down that path, but we're nowhere near to realizing a fully self-driving network yet. But that's what cognitive is alluding to there.
Okay, very cool.
And talking about the architecture of the solution, you guys have a lot of cloud managed devices. I don't know if it's still the keys, but I remember you guys back in the day talking about like white label switches, white label APs. Like, what type of solutions do you guys have today when it comes to architecture, the APs, and how you manage those APs as well?
Sure. So yeah, we lead with cloud. We're cloud first, but we have on-prem as well. So if you want to go with the public cloud, we're instantiated in AWS and Google all around the globe. And if you wanted to do a private cloud, you could do that. Some large customers will do a private cloud build out. But you can also go on-prem. On-prem, either virtual machine for your management platform, or in like a 3-node cluster for a hardware-based solution. And now you almost have full feature parity when you do on-prem versus cloud. There are some things, a couple of things. One, for instance, I have packets here. Now that's packets is that I'm pointing to the tile icon here in the dashboard, and packets is that free packet capture analysis tool that's visually based, right? So you can see the conversations between the clients and the access points in a graphical way, so patterns can be revealed more readily. That is free. So, but that's cloud-based. So if you go with the on-prem solution, the packets won't be included in the on-prem management solution, but you can always use it in the cloud. So you could always, upload captures up into packets. Anybody can sign up for packets today. If you just search for Arista packets, you can start playing with packets. So you wouldn't get that. And another one that you wouldn't get if you did on-prem is Guest Manager. Guest Manager is an analytics / captive portal solution that is cloud-based. So if you were to do an on-prem option, if you were to go with the on-prem management solution, you wouldn't have the Guest Manager. But everything else you would get. You would get CloudVision Wi-Fi. You would get Canvas. Excuse me, not Canvas, but you would be able to do all the management via CloudVision Wi-Fi. I'm also pointing to here another panel called Wireless Manager. Wireless Manager is really where the bulk of the work happens. It's where your wireless LAN configurations are stored and your WIPs configuration is stored, etc. But it has an old UI which is being deprecated. And the only reason why you still see the panel here is because there are few things that you can't yet do in CloudVision Wi-Fi. Once we get 100% coverage in CloudVision Wi-Fi, which was CloudVision Wi-Fi was built completely on APIs, talking to these backend servers, Wireless Manager, Guest Manager, packets, etc. And once we get 100% coverage, and we're in high 90s, then Wireless Manager, the icon will disappear because you'll no longer need to make any configurations within Wireless Manager. Wireless Manager as a server is not going to go away. It's just that you won't be using the UI that's built into that. So just in summary, so you almost have parity in terms of on-prem versus cloud, but you wouldn't get that guest management / analytics solution. Now,
when you talked about...
Yeah, sorry, go ahead, please.
I was going to ask a quick question, Robert. When you talked about that CloudVision was built using APIs, is that APIs that's also publicly available? So if people want to create their own tool, they could use the same API?
Yeah, absolutely. So some of our customers, you can think of some of the larger customers, right? Real tech, titans. They don't use CloudVision Wi-Fi. They build their own interface using APIs. Everything that you see in CloudVision Wi-Fi is completely, like I said, built on APIs. As is true of Nano. Nano is a field provisioning applet. It's built using APIs. You can think of it like a wizard. So to make it easier for field teams to deploy captive portal or just SSIDs, etc. So again, all APIs. And the other thing I should mention, right, is that you talked about white boxes, APs. That's something.
The hardware, yeah.
Yeah, that's something that we used to do. We used to work with some of the third parties, and we would be able to run our code on third-party APs. We no longer do that anymore. We don't lead with that. I mean, suppose we could resurrect it, right? Because we did all the work. We even did provided Wi-Fi at one of the open shows, right? That we had, but we really are not leading with that any longer. But it's still a possibility. What we've done is kind of in another direction, is we've supported open config at the request of some, again, big customers that wanted to be able to use our hardware, but they didn't want to use custom management platforms. They wanted to build their own management platform completely using open config. So our APs do support open config. We're part of that.
I think I know who you're talking about when you say business.
Yeah, they've demos. They've done demos, public demos.
Yeah, exactly.
Right. Yeah,
that's cool. Yeah, I like open roaming. I wish everyone would support it as much as you guys do. But yeah.
Yeah, open roaming. That
open config. Sorry.
Yeah. Open roaming is another one that we're definitely we're looking at for sure. Absolutely.
But yeah, open config is great.
Yeah.
It's great from the network engineer standpoint.
Right.
It's harder to convince everyone to just buy into it, I guess.
Yeah. And since we're talking about architecture, maybe we can talk a little bit about the just in general, like the data plane, the control plane, and the management plane. We've been talking about. I was
going to get into that because you did say you lead cloud first, but then you also mentioned there's on-prem. So I'm curious how the control plane, management plane, data plane, like how all that differs between each architecture.
Right. Yeah. So whether it's on-prem or cloud, we still have three distinct planes, right? One for management, one for control, and one for data. Now, the management plane is the only thing that is going to move, right? Whether if you have a on-prem solution, your management plane is on-prem. If you have a cloud solution, your management plane's in the cloud. The data plane and the control plane, they're independent of whether you're managing via the cloud or on-prem. So the data plane is completely broken out based on SSIDs. So you could have an SSID drop the traffic off locally at the AP, which is fine for a lot of customers, right? Because they're bringing the VLANs out to the edge. But for a lot of customers, as we know, they tunnel that traffic back. They're controller-based architecture, so they're used to tunneling that traffic back to the controller. So you have to have a way for an SSID to get back to wherever that controller currently lives, right? If you're going to migrate with these, and we want to remove all the friction for migrating from a controller-based solution to the Arista solution. And so we have a couple of different tunneling. We can use GRE or VXLAN, standard-based VXLAN. We instantiate a virtual VTEP on our access points, and that way we can then use VXLAN to tunnel an SSID, right, to anywhere in the network that can terminate a VXLAN tunnel. So it gives you that data plane flexibility. As far as the control plane, there is no control happening in the management platform, whether the management platform is on-prem or in the cloud. The control plane is completely distributed, and I mean completely distributed. There's no RM decisions being made in the management, platform. There's some WIPs, that is happening with the management platform, but it doesn't require the management platform. So if your management platform goes away, whether it's on-prem or the cloud, WIPs goes into local mode and continues to do WIPs. But as far as like roaming decisions, right, the sharing of roaming parameters or IGMP group membership, right, for multicast or keys. All of that happens in a shared kind of way in an RF domain or RF neighborhood, I should say, and that happens amongst the access points. So you don't rely at all on the management plane to do any of the control. So what that means is you get high availability. If the management plane goes away, again, whether it's on-prem or in the cloud, the control plane is completely intact. So roaming still happens. RRM still happens, coverage hole detection, coverage hole mitigation, the WIPS, threat detection, prevention, all that continues to still function normally.
So
Well,
how does the AP detect one another, and do they talk over the air, over the DMs?
Yeah, so they listen to each other over the air, and by listening to each other over the air, they develop neighbor relations. But they share the information over the wire. Generally speaking, you can share the information amongst APs and different techniques, but it's generally it's over the wire. So there's going to be communications on the wire side, sharing of keys, firewall, group, multicast group membership, etc.
And does that happen over the GRE tunnel?
No, that's just a proprietary communication happening
Gotcha.
amongst the access points.
And you mentioned different ways to configure the SSID, for example, either dropping the traffic locally or doing it with VXLAN. Can you have two SSIDs, one drops locally and the other one on VXLAN?
Yep. Yeah, absolutely. Let me just jump into the interface. So I clicked on CloudVision Wi-Fi from the dashboard. And then I'm going to click on this little 3-bar there just to open up the tree. And we can talk about the hierarchy, because that's something that is, I wouldn't say unique. It was unique up until about 2 years ago when a competitor also came up with something, I would say, not exactly the same, but at least they do support a hierarchy, and they talk about hierarchical configuration, but there's some differences. But anyways, let me just go to a configure Wi-Fi.
Yeah, because I assume like VXLAN is pretty popular with, or getting popular with, a lot of different network engineers. I hear about it. And I know your switches support VXLAN, so I'm assuming that was a big win for a lot of people once the APs themselves supported VXLAN as well.
Yeah, actually, it actually has been pretty popular, because we're not the only cloud offering for Wi-Fi, and everyone has different ways of tunneling the traffic back. And VXLAN being a standard-based way, it's appreciated. When I talk to customers, they're glad that we're using a standard-based tunneling. And VXLAN,
because you don't really need a controller per se, like a WLAN controller, to
you don't need that.
tunnel this
You don't need a tunnel aggregator.
Okay.
You just use any switch that can terminate a standard-based VXLAN tunnel.
Okay.
Yeah, including Arista switches. So here I'm showing the creation of an SSID. I'm going to jump to the network section, and so you have the network modes. So this is per SSID. You can bridge it, which would drop it off locally. You can NAT it. Now, you'd only NAT in the case where you had a remote office with a single AP. You wouldn't NAT in any type of deployment where you have more than one APs, because if you're trying to NAT, you're not going to be able to roam seamlessly between the APs, because they're going to have different, IP address ranges. So this is, again, just for, the one-off, right?
What network scheme would that use? Do you have to define that, or is that something?
You would.
Okay.
Yeah, you would define it here.
Okay.
And so that's think of casual dining where you have one AP per store, right? A fast food restaurant, or just small retail. And they prefer to use the DHCP server on the access point. So here's where you would, if you want a tunnel, use, and this would be for, you have choices here. You can see the tunnels that were created. If you don't have tunnel interfaces created, you can just say add edit, and here you get to choose the type of tunnel that you want to create.
Yeah, this is very different for a Wi-Fi person, right? Having to know you're selecting a VXLAN tunnel type. Not many of us actually do this.
Right. Yeah, it is. Yeah, it is. Yep, that's for sure. It's kind of interesting though, as we get to more orchestration, end-to-end orchestration, right? If you think about it, we're going to be configuring, these networks from the switch certainly out to the access point, end-to-end for segmentation, end-to-end for QoS, and then, troubleshooting end-to-end for, for application issues. So right now, so you would go here and you configure this. And then you'd go on the switch side and you configure the other side, right? For the endpoint. But you know, you can imagine that in the future it's going to be more seamless.
Okay.
I don't want to talk about it too much, but you know, we're trying to make that an easier task. Anyway, so yeah, so here's what you would do. So it's per SSID. This would be for your remote AP.
And that's remote AP. So
Yeah.
that could be like, so VPN Tunnel Network mode is for like if I had an AP at home.
Yep.
It would
Absolutely.
create a VPN tunnel back. And
Right.
where does that exactly terminate? I guess you have to
Yeah,
define
that is
too, right?
going to be IPsec. It's going to terminate on a number of different firewalls, you know, Palo Alto, et cetera, that can terminate IPsec
Okay.
tunnel.
Okay, so a standard IPsec
Yep,
tunnel.
standard
Okay.
base, yep. So, right.
That's pretty cool. So you can create like a corporate SSID for somebody at home, and then their house SSID,
Mm-hmm.
and that just bridge locally.
Yeah, and like most of us probably don't necessarily need that. Like right now, I'm working on a machine. It's a corporate machine, and it has a VPN client. But I also have a lab at home, and like a lot of us do these days, right? With the pandemic, so a lot of SEs, TMEs, you know, different types of folks, sys people, we have labs at home. And so that's when you could use a remote AP, right? And so you can, everything behind that remote AP is now, you know, is able to reach everything at HQ, at corporate.
Yeah.
It's an extension of corporate, the SSID.
And do any of these features change whether it's cloud managed or on-prem?
Let me think about that. For these, so for this all here, no, none of this is going to change. This is all going to be the same whether there's cloud or on-prem.
Okay.
Yeah. Where you would see things that would be different would be going back to guest manager. So
Okay.
you wouldn't have, if it's on-prem, you wouldn't have this guest manager tile
Gotcha.
at all for an on-prem solution, because guest manager is only instantiated in the cloud.
Yeah.
And again, packets would be, it wouldn't be show up as an icon here, but you could, you know, you could open packets and you could upload your captures.
Yeah.
Yeah.
And as far as the data plane goes, we talked about tunneling some traffic. None of the data though goes to your cloud, right?
And that's right. Yeah.
Okay.
Yeah. No, user data doesn't go there. Of course, statistics go there, you know, of
Yeah.
your client statistics, right? The data rate, you
But
know,
not the data payload where
that's right. None of the payload. As a matter of fact, you know, we do have a feature, and we'll probably get into this when we do talk about troubleshooting, but we have a feature of automatic packet capture, and automatic packet captures are going to go into up to the cloud. But before we do that, we strip the payload and we encrypt the packet capture.
Okay.
So,
Yeah, that's good to know.
Yeah.
Yeah, because I know there's some environments that don't allow, you know, some data to go externally to any cloud, but that's good that you can strip that data payload, and then you actually encrypt the packet capture and send it to I guess packets, right? That's where it's going. Okay.
Yeah. Yeah. And that's when you have now this, I should say that this setup, this is a simulated environment. So there are some things that aren't quite the same as if it were with real clients. So talking about that automatic packet capture, we have what we call here the client journey dashboard. And it's one of 4 really important dashboards in terms of a cognitive, you know, self-driving network. And we see here this the client, as it goes along its journey to get on the network, it goes through the association, authentication, and network stages. And if there are any types of issues along the way, whether it's at the association level stage, and you can see here we have 11 clients. And we look down, I'm looking at this pop-up, and we see of the 11 failed clients, or clients that failed at the association stage, we have 3 that maximum association limit was exceeded. 5 were association capability mismatch, and 3 association failure. Now, if I were to click on, well, it's just changed. Now it's down to 6. That was interesting. If I were to click on that, I could see the clients that actually had a problem. And I look over here and I can see the last failure reason. I can get that information. If I look, I can see for a Motorola client, right? I can see that there was an association capability mismatch listed in the last failure reason. So I can probably leave it at that. But if this were a real client, and it's not a real client, but if it were a real client, there would be a packet capture. And I know it's not a real client because in this demo system that we've created, if the client doesn't start with the letter R, it's not a real client. So I could click on that, but I won't see a packet capture associated with that. And so
all the problems are on 2.4. That's what I've noticed.
Yeah, and but it shows that the reason for the failure, and it says a client capability mismatch, and then it gives you, a way to maybe, check the, what you might have. You may require a certain data rate, for instance, that we've disabled, and that's why
data rate or like 11R is enabled, but the client doesn't support it.
Perhaps
kind of thing.
11R may be enabled and it's not mixed mode. We do have a mixed mode where 11R will allow non-11R clients to also connect to the SSID, but yeah, that could be it.
Okay.
So you don't see packet captures here, but if they were real clients, there would be a packet capture. Like I said, you'd have the ability to either download that packet capture and then open it up in Wireshark, or you could open it up in packets and view it that way.
Okay. I mean, it's really nice to see the actual client event. There's some dashboards where I see that there's just association errors, but it's not very clear as to what those errors would be.
Mm-hmm.
I don't think I've seen anyone say there's a capability mismatch. Well, I haven't seen anyone actually say that, and I think that's pretty cool to see that there, especially when people are making various changes to the Wi-Fi network, and then all of a sudden you've just kicked all these other devices off because of that one feature you enabled.
Yep. Yeah. And then, yeah, so that was a correlation, right, with a change that they can be, causing a problem. But another way to do correlation, what I just did here is I'll go back. I see that we have 9 clients that had trouble with authentication for various reasons: radius authentication failure, radius server unreachable, radius server not responding, incorrect PSK, ePOL handshake failure. If I click on those clients, I can then see this little pie chart. And so this is a way we can try to correlate issues with the particular OS or model of a client. And then we maybe can correlate back to an update. Like for instance, here we only have one iOS client that has a problem. But if I had a problem with the association authentication, and all of a sudden I saw that we had, all the clients, or most of the clients who were having that issue were associated with an iOS update, that would lead, we say, oh, we got to look at that. That update caused some problems,
Yeah.
So
they all enabled private MAC address.
Right. Right.
Can you see this? Can you see this information on the timeline?
Yes.
And see if all the issues happened at the same time, for instance.
Yeah, you can. You can go back to 1 month, and so we baseline everything. And you can go back to 1 month, and then you can see if the problem started showing up at a certain time, like shortly after that new update, iOS update was available.
Yeah. And then I'm assuming you could also narrow that down to like maybe a very specific band, because you may put like certain devices on 2.4 and certain on devices on 5, or maybe it's a certain SSID that you're looking at versus all of them.
Right. Yep. It will show you the band as well. Let's see here. It's all on 2.4 in this case.
Oh, you're right, Francois.
I told you, that's what jumped out to me, and when I saw
it's all 2.4.
Yeah,
I do like the time. I do like the timeline view, being able to see that quickly and go, all right, something did happen on this day and this time. There was a change request, that got put in, and then that affected everybody.
Yeah, baselines is big, and these baselines are self-learned. They're not. We don't set limits for these baselines. Baseline is derived from what's normal, and what's abnormal then will show it as outliers, and they'll be highlighted in red. We can see that too for the performance dashboard. So the connectivity dashboard obviously is all just concerned about connectivity, whereas the performance dashboard is really concerned about network and client performance, or network service performance, whether it's AAA, DNS, DHCP. And you can see we have different categories of client health: low RSSI, high retry rate, sticky clients, low data rate. We also have dashboards. So, the baseline. And again, the baseline, you can go back. That
client health tile there is already interesting, because that's looking at all all
Mhm.
clients, and is this just an average of all the clients?
No, those are individual clients, and these are thresholds that you can change, by the way.
Because I like the high retry percentage. So that's
Yeah.
saying 45 clients have high retries.
That's right. And that's for the whole org. So you
Oh, I
see
see.
how
So
I have this highlighted up
yeah.
here?
We're
Watch
going
this
back to the hierarchical view.
Yeah,
So,
back to the
okay.
hierarchical. Thank you. I'm at the top of the hierarchy here for the whole XYZ Corp. If I were to go down to, say, one office in New York, how many clients do I have there? Do I have any clients there? No, I don't have any that are having trouble. I'm going down to another office. Okay, so I'm in New York now, and I'm at the FHQ S3 location, and I see I have 15 clients with low RSSI. And we see that it's just for 15 clients, the signal strength is below -65. And this is real time, as opposed to using the baseline. When I use the baseline,
yeah.
now I'm going back in time. But this is real time. So these are clients that are currently having issues. Now, it says -65. Now, where the baseline is derived automatically, these thresholds, some of these anyways, you can actually change. I'll go back up to the top and show how that works.
Okay.
If I go back to the top here, the hierarchy.
Yeah, because I'm curious if that's just a client that just went to -65 or worse for 1 second. Like, what's the?
It's live. It's happening now.
Okay.
Yeah. These are for clients that are having these issues currently. Yeah. And it's almost real. It's like, you can think of it as real time as opposed to historical.
Okay.
If you want to go back and look at clients that had trouble in the past, you would use the baseline to do that.
Gotcha.
Go back to that point in time. But here is where I'm showing where you can set up the thresholds, like for low RSSI. You can change that. If you designed a network more for coverage than capacity, you could change that. Or even if you go with wider channels and you say, -65 was fine for 20 megahertz channels, but we're going to be bold. We're going to start designing networks with 80 megahertz channels. So now maybe we want to, drop this a little bit to -62 or something like that, right?
That's very bold.
You could do that. And then here
6 gigahertz is coming, right? Well, we'll be playing with 320 megahertz wide channels.
Yeah, right. So, and here too for data rate. So if you're designing for a high density network, high capacity, you can adjust your data rates.
Okay. I'm also curious about that sticky client section. Like, how do you know a client is sticky? Yeah.
So we know it has to meet certain conditions, right? You have to have a client that is at a low signal strength. And then there also has to be an access point, one or more access points nearby that would do a better job of servicing that client. And then the client can be called a sticky client. Now we have smart client steering. It's not enabled by default, but if you enable it, the smart client steering is going to nudge those clients, right, that are classified as sticky clients. It will nudge them to try to, basically encourage them to prompt them to connect to an AP that's nearby that would be better for that client and better for the network in general, right? Because we know sticky clients don't just slow down things for the client that's stuck to the AP far away, but they lower the capacity of that cell, that radio, right? Because they're gonna, So anyway, so that's what that. And so if you had a sticky client, and the system would most likely say, assuming that smart client steering was not enabled, the system would say, you should consider smart client steering.
Yeah. And how does it nudge a client? Is it
deauth it? Yeah, it'll deauth it, but it won't do it forever. Like it'll only try so many times. And if the client is persistent, or we call it a desperate client, a client that desperately wants to hang on to its AP that's far away, well, after a while, we're like, okay, we tried. Go ahead, do what you want to do.
Yeah, because I've seen that as a problem with other vendors where it's more like a load balancing feature, and so they're just continually deauthing, saying, don't connect here, and it just keeps doing it, even though the client wants to, over and over again. Yeah, you're right. Different clients behave different ways, obviously, right? And so when we developed the sticky client feature. And we weren't the first. I won't mention who. We probably know who the first was. But just like with them, there was a lot of trial and error, and we also had trial and error. At first, it was pretty crude, but over time, we refined it, and we got better at dealing with different types of OS, different types of clients,
And so
But I do like
we had
that you stop doing the deauth at some point.
yeah, exactly. Some clients they're not going to like it. They're just going to
Okay.
remain sticky. So we had to be able to deal with all those different types of clients.
Yeah, so I really like this performance dashboard view because it does give you a sense of like some metrics that some organizations try to aim for when it comes to the performance of all, their Wi-Fi network. And I guess if we look at this hierarchical view, you can do it at an org level, but then at a sub level as well. So whether you have multiple sites in a state or a region or different countries, that's what it looks like here, because you've got India, North America, and then different cities underneath those subsections.
That's right. The hierarchy it's really cool in a lot of ways, really helpful. So obviously it was primarily designed for the customers that had large distributed organizations. And some of our first Wi-Fi customers, a lot of our WIPS customers were that, right? Very large, thousands of locations throughout the globe. So the hierarchy really helped. And it works in terms of configuration push. So you can do a configuration at the very top of your hierarchy, and then you can have a total inheritance throughout the whole organization. And it might work for some customers, but there are going to be, more than likely, there are going to be places where you want to customize. So you can break the inheritance anywhere you want to break the inheritance, and you can customize at the location level, or you can customize at the AP level or group of APs. For instance, if you had, let's say you have throughout your organization, you have 7 high density locations. You have a number of conference rooms or other types of high density areas. And for those high density areas, you want to use the same SSIDs, but you want your APs, your radios, and your channel widths, et cetera, to be configured differently. And you want load balancing turned on across the APs to accommodate a high density area. So you could have a group called a high density group, and that high density group would then contain all the APs throughout the whole organization that really we need them to operate in a high density configuration. And then you could have those that high density group applied throughout the hierarchy. So the same SSIDs as the other locations, but in the high density areas, you've got APs that are 20 megahertz. You have load balancing enabled, your transmit power is lower, et cetera. And so you can customize at that level as well. And then you also have the ability to customize at the individual AP. So you can turn off 2.4 gig radios, for instance, if you have 2.4 gig radios in a certain area. So you have those 3 levels of customization, and that's for configuration. But the hierarchy works in both ways, right? So in terms of reporting, I can go up to the top of the hierarchy and I can run any number of reports. We have a lot of canned reports here. So we have WIPS reports.
So you can compare the performance then of each location. Against
that's
each
right.
other.
You could, and you have your compliance reports that you can run at the total, the total at the highest end of the hierarchy, your alerts, et cetera, and your WIPS. Or you can go to a particular location in North America and just run your reports for that location. Or you can go to a city and run the reports for that city. Or you can go to a location and run the reports for that location in the city. So you have that.
I imagine then, like, for example, an org this big probably has dedicated IT people for that region. So then you could probably create those canned reports and have it sent to just those individuals.
Exactly. Sent to those people that are responsible for that part of the network. Same thing with alerts. You can set up alerts to go to the administrator associated with New York, right? So so you have that level of alerting and reporting. It's all location based. And I should also add too, we didn't touch on this much, but in terms of the hierarchy, we have role-based access, right? So you could have network administrators that can do everything, and Wi-Fi and WIPS, and then you can have those that can just configure WIPS, or those that can just configure Wi-Fi, or you can have some that can view everything, right? But they can't change anything. But you can also have a marketing manager that can only look at your marketing campaigns, right? With your guest captive portal and your engagement, and so on and so forth. And that's all they can do is manage marketing campaigns. They can't do any WIPs, they can't do any wireless LAN, et cetera. So you have a level of granularity in terms of role-based access, but then that's also tied to the location.
Yep.
So it's a pretty
Could
powerful.
you, if you have one SSID that you want to broadcast in multiple buildings, but then you're using different VLANs
Yes.
for these different buildings, do you have like a way to use like a VLAN variable, or
Yes.
you know what I mean? Okay.
Yeah, that's a great question. And, it's a new feature. I think it's, what is it, Metka, 6 months old, something like that. We call it named VLANs. And yeah, so you have that ability to use the same SSID throughout the org and use different VLANs for different locations without having to create different templates.
Okay.
Yeah, it really simplified things.
Yeah. So you then just define that VLAN at the location hierarchy or the building hierarchy.
Right. Yep. And
Okay.
so that was a relative,
VLAN name.
yeah, like I
Okay.
said, yeah, set SSID VLAN mapping here. And so this is a feature. I'm showing it in the SSID, basically the VLAN, and then there's an SSID VLAN mapping.
Okay.
So you would say which side goes to which VLAN.
Yep. Right.
Yep.
Okay.
Yeah, that would be, I've seen a lot of sites use that. Now, so we're looking at this hierarchy view. How does it work if you want to provision an AP? Like, how do you know where it's going to land?
Sure.
When somebody, you send an AP to India, how do I know it's going to sit there in India, or is it going to go to kind of a provisioning section?
Right. So let's talk a little bit about what happens when, the life of an AP. So you're a customer, new customer. First of all, you won't have all of these folders created yet, right? So you'll just have your customer name here at the top of your hierarchy, and you'll have the staging area. And when you purchase APs, your APs will show up in the staging area. That means that you don't have to claim the serial number or the sales order number. The APs will just show up in your staging area. Now
so
that's
you do that
before
in
you
the
ever,
back end.
Yeah, that's all done by the sales order team, and we have a customer provisioning portal, and that associates the APs that you purchase with your cloud account. Now that's before you ever, receive the APs. They're going to show up. The serial numbers, anyways, will show up in the staging area. And the staging area, there's no configuration associated with the staging area. So when you get your APs, when they physically arrive and you take them out of the box and you plug them in, and they would need to get an IP address, and they need to reach the management server, whether it's in the cloud or on-prem. And here we're talking specifically about the cloud. So the AP will go out to the cloud, right? And it will go to this entity called the redirector. There are many redirectors throughout the world, but the redirector then says, oh, okay, I see your serial number. Your serial number is associated with this cloud instance, this cloud account. So from now on, you're going to go to this server in the cloud. And so that redirection happens. So there's no claiming of access points by serial number, right? There's no app that you need to open up and scan the back of the access point so that it gets associated to your cloud. There's no license to assign to your access points. It's all done in the back end. And the APs find your cloud instance, your cloud server, just by going to the redirector. So your APs are up online. They don't show up here online, but you have this. You would have it active. It would be green. It would say active. Once the AP goes out and finds your server in the cloud, but it wouldn't have a configuration. The next step would be to create a folder, and then go and configure your Wi-Fi, SSID, and then the final step would be to move the AP to the folder. Now, you can do this. There's a number of ways to do this. One way is to simply go to the access point and then click on those three dots to the left, and then say, move the access point. And then I could select the folder to move the access point to. That's okay if you have a few APs, but you can use the APIs to do this. So you could do it based on, it's a small script, it's a few lines long, and it's basically based on the subnet that the AP gets, then assign it to different folders to do that.
Like auto provisioning of the AP, right?
Yeah.
And you can do it based on the subnet. Okay.
Right. Nice. Exactly. Yeah. Way better than doing it manually if you have a lot of APs.
And how does it work with software versions? Like, is it possible to have
Sure.
you know, India on a certain software
Yeah.
version and America on a different one, or do
Absolutely.
they all have to be the same?
Yeah. So let's see here. So I'm at the top of the hierarchy, and I would say firmware update. And actually, before I do that,
Update everything right now.
yeah, I could go to, let's say I want to go, I'll go to India and I will look at the access points and I can click them all. And then I'm going to, you know, I can say update. Now I can do the hitless update. Hitless update is just a automatic update to prevent coverage holes. So the APs are aware of each other, so to speak, and they are going to make sure that they don't upgrade all the access points for a given area. So they're going to minimize the possibility of there being a coverage hole. So you could do this update during business hours.
Okay.
And then scheduling updates. Now, to your question, we can run different versions on different access points. So we could sort by the different models of access points, and then we could say pick the version that you want. And you can run any number of versions, right? And even older, like if you have very old access points that don't run the newer version. So
Like
I'm going to go
mine,
with C65. So you
I feel like you're talking about my AP.
yeah, exactly. So yeah, see the code that you're going to be have available. It's much older. We're on 11. That's the latest release, 1101. But for the C65, it's so old it wouldn't support that. So, but that AP would still be able to run. You could still be able to configure, you know, SSIDs, and it would still be able to do whips. But some of the newer features, well, the newer features that are code dependent, right? Obviously, they wouldn't support those features.
Yeah, so someone doesn't have to get rid of the older APs just because, you know, if you try to go upgrade to a new version, they're not going to be stranded.
That's right. Yeah.
Okay.
Yeah. And you know, some controllers these days, you can run multiple versions of code on access points, but that's a relatively new feature, right? Because for a long time, when you updated a controller, every access point on that controller would use the same code. And for some competitors, I think that may be the case still. But for us, we've always been able to have different versions of code on different APs, or, you know, different models of APs, or even you could 260s could, you know, half of your 260s could be on code 11, half on code, you know, 10.
Okay. So, I mean, speaking of the APs, can you go into, I guess, some of the features of the APs? Do you have I'm assuming you have AX APs now? Are you gonna you have 6 gigahertz out now? Or?
Yeah, we announced the C360, which is a 4 Wi-Fi radio and access point. It also has a BLE radio, which actually it's Bluetooth, BLE, and also Zigbee. But there are 4 Wi-Fi radios. One for 2.4 that's locked down, another for 5 gig that's locked 5 gig. And then we have another one that's both 5 gig and 6 gig, right, configurable. And then we have a multifunction radio, which is tri-band for, well, we can give multifunction is super important. We can talk about that all day. And
you can do whips
like
on it,
captures and whips.
Yeah, the multifunction radio is important for over-the-air packet captures. It's like having a discrete sniffer there. For whips, over-the-air prevention, you know, because you can't use your access radios to do effective over-the-air prevention because they would have to be taken out of service for too long to do that. For scanning too, if you think about doing RRM scanning, if you're trying to do RRM scanning in background, especially with 6 gigahertz, you know, so having a multifunction radio that it doesn't have to service clients, and then also for active network assurance, where you're instantiating a virtual client in that multifunction radio to associate to adjacent APs and do all kinds of tests, not just over the air, but out to the cloud. So having the multifunction radio, and then also spectrum analysis too, rather than try to do spectrum analysis, where you really can't do spectrum analysis effectively in background scanning. You'd have to take a radio out of service. So yeah, so that multifunction radio.
Could you use it to do like DFS scanning as well? I don't know.
Yes, it does DFS scanning. It does the RRM scanning, including DFS channels.
So truly multi-function radio.
Yes.
Basically offloads the work of not having to do like an off-channel scan of a radio that's serving clients.
The name of the AP says it all. It's 360. It does everything all around. Right? It's a great name, right?
Yeah, and it's a 4x4 on the 2.4, 4x4, 5 gig, 4x4 on the 6 gig. And so it's really our flagship AP, and the BLE, Bluetooth 5.1, and then also a Zigbee radio. So, I mean, it's all in one. And so,
When
yeah,
is that
Do you
available?
use the
10 gig
BLE
uplinks.
for?
Sorry.
I was gonna say, do you use the BLE for location?
Yeah, we are.
Okay.
Yeah, so right now we all are, our AP's BLE Beacon, but in this coming release in Q1 of next year, we're going to be doing BLE sourcing RSSI, et cetera, to locationing engines, as well as doing sensing for WIPs for IoT.
Okay.
Right. So yes, we're definitely, pushing, we're going to be moving in that direction, because we already support wireless LAN locationing, and, with wireless LAN, with the latest, time of flight. So wireless LAN, we haven't given up on wireless LAN locationing. Certainly time of flight is something that is very exciting, and we're actively, pursuing that. Who isn't? But we still, we know that a lot of customers, want to do BLE locationing. So we're working on that.
Even for troubleshooting, I was thinking about it the other day, taking a look at the solution is, it would be nice to know when I had issues where those clients were on the map. So you can kind of correlate the two and say, okay, yeah, I see a lot of, clients having issue in a specific location on my map. Is it because I have like a coverage hole or an AP not working? You see what I mean? Like we could kind of correlate the two.
Yeah.
The time and the location.
Yeah,
That's right. And
so
we
you're saying,
have
Robert,
that
you could
capability right now. I'm showing you that this is
Okay.
what we call cognitive mapping or cognitive maps, where we can correlate issues with locations. So we can correlate any types of performance issues, whether it's low RSSI, low data rate, high retry rate, sticky clients, or poor application quality of experience to a location. And also for connectivity issues, association failures, authentication failures, and then network failures. So you see the access points here on the map.
Yeah.
And if I want to find out, like, well, the authentication failures that we're seeing, are they associated with a particular area of the network? And this is a simulation, so it's not perfect, but you can see that shows us where on the map the clients are having authentication failures.
Okay. And is that based on just RSSI, like where that location?
Yeah, these clients are being it's a trilateration from Wi-Fi access points in real time. So when I clicked on this, it basically did that trilateration for these clients. It
so
already knew which clients were having. Sorry?
I was gonna say with BLE, you could get like maybe a better accuracy or something.
That's right. Yeah, with BLE, we would expect to get potentially, if you had a dense enough deployment, right? It comes down to, well, same thing with Wi-Fi. We could get a better accuracy location. But, really, I think the promise of time of flight is really where we're going to get the type of locationing that opens up other possibilities as well. And
do you want to talk about that a little bit?
I can only say that we are working on it, but that's not a surprise. I think that and you can assume that every Wi-Fi vendor more or less is looking into it, right? Because it's becoming part of the standard in our AP supported. A number of our APs really already support time of flight locationing. And so, Qualcomm, and not a surprise or a secret that we use Qualcomm, and they're definitely proponents of it. So, yeah. And I think that's going to give you better location. I shouldn't say I think. I'm not an expert per se. I don't consider myself an expert in locationing, only because I haven't spent years in the lab testing different solutions in terms of locationing. I spent some time, but I think the experts agree that time of flight is going to give you better locationing than BLE, and even BLE angle of arrival, angle of departure, and so that's very promising.
It's a big claim.
Yeah, it is. It is. But speed of light being what it is. Here's the trivia question. How far does can you travel going at the speed of light in 1 nanosecond?
Should we bet something?
I'll lose that bet.
I didn't know. I had to look it up. I was just curious. Right? I was wondering about the precision of the clocks to give us like really good locationing. It's at 1 foot approximately in 1 nanosecond. 1 foot. It's kind of interesting.
I was going to say 1 foot, but I wasn't sure, so I didn't say.
So,
Nice.
so anyways, so yeah, that's pretty, but for now, we have an approximation here where the clients would be. And when we first came out with this feature, which is probably a year and a half ago now, it wasn't so accurate. So we had to go back to the drawing board and refine it. And now it's fairly accurate.
Okay. I do have a few questions about this map. Is this where you have to manually place the APs, or can I upload like an echo file? And
that's good. So yes, for now, it's still manual. However, we've been waiting, eagerly for the Echo House service, right? Where we upload these site surveys or these, plans, placement plans into the Echo House site survey, and then using APIs to pull it back and down into our solution here. Now we don't have that feature yet, but it's something that we're looking forward to. That's kind of a thing.
My second question is, okay, you're showing in this example, there's authentication failures and where they're happening. What do you do then in this view? Because I can see them, but what's the next action item from there?
And because this is a simulation, it doesn't really tell us much in terms of these authentication views, right? If we had, for instance, all of them were here in this area, then we might start thinking, okay, what is it about this AP in terms of the radius configuration, maybe, right?
Yeah.
Is it pointing to the right radius server? Why are the authentications happening here? Or if it was, say, for instance, if it was a poor coverage and we saw all the poor coverage here, we start thinking, what's going on with this AP? Or maybe it's out of commission, right? Is it really? And you could always do the coverage maps too, by the way. You can do heat maps, right? The traditional. So you could then maybe look at your coverage and see if there's a coverage hole.
Oh, okay. So place a actual signal heat map there on the map.
It's working on it.
And it's working. Is it using the data gathered by the client devices?
No,
okay.
That would be awesome, right? That would be awesome if you think about it. If you had that super accurate location that I was talking about, and if these clients were using 11K or something, right, to say how they see the network, then that would be able to inform your RRM algorithms much, much, much better.
Is it
right?
based on
Everything
how the
defined in the
APs
standard was implemented, our life would be easier.
Yeah, exactly. No more having to go out there with a sidekick, right?
Yeah, we probably wouldn't be having this recording.
Yeah, exactly.
So yeah, if you had that, if you have really accurate locationing, and you have enough clients, a diverse set of clients telling you how they see the network in terms of signal strength, etc. Now you have like a full-time, site survey.
So is this heat map then based upon how the APs
how
hear each other?
APs, it's basically,
Gotcha.
all from AP's perspective.
Okay. Maybe we can apply.
So that's the
offset.
idea, is that you would be able to correlate issues with certain locations, and that could help you get to the resolution quicker. So
how about then troubleshooting a little bit more detailed? Let's say there are a bunch of clients having issues, or you get some tickets that say, hey, Wi-Fi is not working, and you identify the client. What can we do here in terms of troubleshooting? First place I would recommend starting would be, generally speaking, you're going to your dashboards. If it's a connectivity issue, then the client connectivity dashboard. And if the problem's happening currently, you'll see it here. If the problem is historical, then you'd have to go back, and actually, let me rephrase the question. What if they say like Zoom sucks? That's a if they say Zoom, not to mess with Zoom, but I'm just. Oh no, let's say how about let's pick on GoToMeeting. Nobody uses. I love nothing against GoToMeeting. Now, come on, I used it for years, and I'll use it in the future. But nevertheless, we have an example here where we have, again, this is a CAN demo or a simulation. We have an example where we have some clients are experiencing poor experience with GoToMeeting. And so now GoToMeeting is a real-time app, right? So we're looking specifically at video conferencing. So I'll stay here for a moment. This application experience dashboard, it doesn't just look at and report the quality of experience for real-time apps like Zoom, like Teams, like Hangouts, etc., like Skype, GoToMeeting, but it also can look at TCP-based applications.
And when it looks at TCP-based applications, it's not looking at a what I like to say is a golden flow. It's just looking at TCP, statistics basically. But if you're talking about real-time apps like GoToMeeting or Zoom, we model that with a support vector a machine model basically. And what we're doing there is we take what are good, right, known good conversations or flows for the various applications, and then we compare what we know is good to what we're seeing in real time. And if we see a deviation in terms of bit rate or jitter, etc., we will then report it as possibly a poor quality experience. And that's what we're seeing here. We're seeing a poor quality experience for some clients. So if I click on that, I can then see, and then scroll down a little bit, I can see some of the clients that are having that bad experience. And I can look for maybe one that's having a really bad experience there.
Yeah, because would we be able to correlate that with something on the Wi-Fi side, or just be able to say this is an application or something on the internet type of issue?
Yeah, we can. We look at both the wired side, and then we also look at the wired side, Wi-Fi side and wired side. So when we compare the flows, we look at the wired interface and we compare there, but we also look at over the Wi-Fi interface and compare there. So we can point to whether the problem is a wired problem or a Wi-Fi problem.
Okay.
Oh, thanks God. Thanks God. We're good then. It's not Wi-Fi. It's not our problem.
Yeah. And I just clicked on Thomas's client there, Thomas's tablet. And Thomas's tablet is facing low. The reason why they're having trouble with GoToMeeting is that they have low RSSI. And the reason there is poor coverage. So I can then look through the light bulb over here, and I can click on that, and the light bulb will give me some remediation recommendations. One is to consider adding more access points at the location. So basically, it's saying this because it thinks that the configuration's fine. If they thought there was a problem with the configuration, they would recommend changing the configuration. But in this case, they're saying that, okay, the config looks fine, but it looks like you might have a coverage hole. And so considering access, adding more access points.
You should customize the message and be like, send Thomas an AP or something like this.
Yeah. Or what we'd like to see is show you where on the map, right? Pop open the map
add it
and say, here's where we
good.
recommend you add the access point.
Yeah, because then you could see, because I think it would be good to see the map, because if there is an AP there on the map, but maybe it's down, that's something to consider as well.
That's right. Yeah. And so this is, I remember I talked about this is a start of the, the path that we're on in terms of self-driving network, but it's still early days, right? So at some point, I remember it was 3 years ago, Mobility Field Day 3 or something. I don't remember which one was. The delegates were asking, so yeah, you do this root cause analysis, and they were just asking us, they were asking competitors as well. You do automatic root cause analysis, you do automatic remediation recommendation. When are you going to just do the remediation, right?
That's
automatically.
A common question.
And that's a common, And so we still, we're not.
There's still
quite
a lot of
there
work
yet.
to get. It's not. We've been doing it with like channel changes and transmit power, but beyond that, there's not like maybe data rate changes. Maybe someone set the data rate too high. It could automatically change it to lower the minimum.
Yeah, exactly. If you got an environment that's noisy and you're never going to be used to high MCS rates, then disable them, right? Rather than waste all this airtime, clients to try to use the high MCS rates when they're not going to be able to because of the noise floor.
But then you have clients that don't play nicely with that, and they freak out because the high MCS are not enabled.
Yeah, that's right. They're unhappy. Yeah.
So it's tricky.
It all comes back to the clients.
It is tricky.
It's true. In this case, it does, because if we had all of the clients supporting all of the standards and supporting 11K and V, then that would be easy, right? You just talk to them and they answer and they talk back to you in the same language. But because we have, widely, we have like different supports from different clients. Sometimes, they don't speak the same language. Sometimes they understand, but they don't do anything. So it's hard to kind of find a solution that will fit any environment. Like it's really tough.
Right. Yeah. And the whole goal is to improve network performance, improve customer satisfaction, right? To save them OpEx. I mean, that's the idea behind the self-driving network, is so that our customers don't have to waste so many people hours, right? Work hours, keeping the network up and running optimally. That's good for the customer, and it's good for the vendors too, because the vendors don't have to field as many TAC calls.
Yeah.
Right. So that's the goal.
I think that's where we're trying to get to, is not just TAC calls, but also service desk calls. Because one of the things I'd like to see, like in the reporting and alerting area, is where you leverage either AI or ML to just help automatically determine that, all right, there's this issue that's occurring, and the longer this issue
Like being proactive,
arises, like have this severity come up and somewhere, and even have it automatically say, hey, look, this is not even a Wi-Fi issue. There's like some service impacting GoToMeeting, for example, like something that would just stand out and be able to tell everyone that, hey, you may be getting a lot of service desk calls because, GoToMeeting is a common application used in the org, but the problem is GoToMeeting and not the Wi-Fi network. Because I've seen that happen several times with some of these applications.
Yeah, right. On that point, we can look upstream now, and we can see if the applications that the problem is associated with the wired side. We can then do rudimentary root cause analysis if it's associated with like latency. That's something that we introduced a few months back using green tea, basically this postcard methodology of determining latency from switch hop to switch hop. And we can correlate that latency with an application performance on the wired side. We're going to definitely be doing more of that, wired to wireless, troubleshooting going forward, obviously. That end-to-end troubleshooting is the next horizon. So on performance side, though, you mentioned service. So we do track performance of services, AAA, DNS, DHCP, and we can go back and say, we can look at the, say we want to go back 1 week to look at DNS performance. So let's say on November 26th, we had a lot of people complaining about application performance. We can go back and look and to see if we had a lot of high latency at that point in time. Or people that were, in this case, it's not too bad, it's not really high at all. But if we were to go to say AAA, people were complaining that they weren't being able to log on, they were having trouble logging on to the network. And we can go back in time and see if there was any trouble with the AAA server.
Yeah.
And then you could go back, I'm assuming you could click on a client and go back to the user journey.
Yeah, you can, but yeah, if you want to drill down a particular client, you can do that. You can focus on a client and go back through to see what that client's experience was over time.
Yeah, because that historical data is probably what we look at the most, right? First of all, how often do you get a call and the issues occurring right then and there? It's usually like, hey, yesterday,
in the past.
Yesterday I had a meeting and it didn't work. Zoom wasn't, like what they say is Zoom kept saying my internet was unstable. Or
So you can go to a particular client, and then you have two different views. You have this graphical view and show all of the issues that way, or you can go to the table view and scroll back.
And that's still looking at that client from that timestamp you're looking at?
This is over time.
Okay.
Yeah. So
it's a lot of problems with that client.
Yeah. Again, it's simulation. So So you have the ability to go back for just whatever it is, an application over time, or service, AAA, etc. over time, network performance over time, but you can go back for a particular client too and look at that client's experience over time.
Are you guys trying to get more information from the Radius server? Because I find like in the Wi-Fi dashboards most of the time, it would be very useful to have information from the Radius server when we have issues, so we know if it's like a user entering a wrong password or a certificate issue, or just the Radius server being down. a whole bunch of issues could be could be happening for us
Yeah.
in the backend. So if we could have somewhat access to the logs from the Radius server, then if we have a user coming in and setting like putting the wrong password on the .1x authentication, at least we can find that out instead of just
Right.
saying we have an authentication issue and go back
Yeah.
to the Radius server.
That's right. Yeah. So like I'm showing now the authentication issues, and some of them are Radius. Is, one of them is an incorrect PSK. Incorrect PSK is pretty, pretty clear. But you have an authentication failure. Okay, why? We have a handshake failure. Maybe why. The Radius server not responding. That's clear. But when there's Radius authentication failure, to your point, yeah, we'd like to. And we talked about that, getting more information.
Yeah. Yeah, because is that the AP
right.
that doesn't have the right key shared secret with the Radius server, or is that the user not having the right password on their account?
Or trying to do a machine auth when you really should be using
client
user auth,
certificate,
etc.
Yeah.
Yeah, and right. So if there were a packet capture, you could then get more of a clue, because then you're looking at the actual conversation between the client. But in this case, because it's not a real client, there's no packet capture.
Yeah.
But even with the packet capture, like if it's a tunneled EAP method, like PEEP or something else, then the authentication is happening within that tunnel and everything is encrypted. You see that it's not working, but you don't know why.
Right.
So, but maybe with the new, I'm thinking maybe with the new way of doing things, maybe we can have NAC solution that have APIs as well, so they can integrate with your solution or any other vendor solution, so we can have some sort of feedback whenever there is an authentication not working on the Radius server. We can have some data back to the Wi-Fi console to tell us why.
Right.
Maybe that can happen in the future. I don't know.
Yeah, that's definitely come up. I can't say for sure what we have on the roadmap there, but it's definitely come up. And I'm looking for some packet captures if I had an example. I do have in some of my decks, but I'm not sure if it's a good time to open them up, where I actually have examples of Radius authentication failures, and and again, you can see. Let me just open up any one of these just to show the level of detail.
Because Francois, are you referring to like having them even read the PCAP and then just display?
Well, so even if you read the PCAP, sometimes you won't know why it didn't work because the data is encrypted. The only way you can know is by
from
going
the
on
Radius
the
server.
Radius server on the logs, and it would tell
So
you,
have a tie-in. Basically, either use API or some sort of logging
logging.
the system could read.
Exactly. Yeah, to correlate, right, as an input into another set of data coming into your client journey dashboard.
Yeah, instead of just going there and seeing we had an authentication failure, you could just clearly see, the user Francois didn't use the proper password, right? Or you can say user doesn't exist on this in the database.
Yeah. Which would be best from the Radius server rather than.
Yeah, exactly. And then and then we could go back and then ask the user to kind of try again or make sure the password is fine, or have a better idea of what happened, pretty much.
Well, we don't have too much time, but we were talking about troubleshooting. So I'll just quickly, if we wanted to talk about some of the, so we will go into client connectivity tests, and that's one that we'll cover in the next episode. I think network assurance, that's part of the active network assurance, where we instantiate that virtual client and to test not just over the air, performance or availability of the SSID, but we go all the way out to the cloud and test applications. Let me just give you an example here. So with client connectivity tests, and of course you can schedule these tests to run before the bulk of the workforce comes in. They can run during the time of the peak hours. It's just another client doing what clients do. It does not service disrupting at all. But we have the access point acting as a client. So that's any AP that has has a multifunction radio. And then the AP under test. And the AP under test is just the way that the client starts doing the test, right? Because we're not just testing that connectivity over the air. you'll see, so we have association, we're looking at authentication. In this case, it was AAA. We get the latency, 5.2 seconds, which is really long. Then DHCP, the particulars, the IP address, the server, the DHCP, the gateway, and the latency to the gateway out to the internet, DNS latency in your DNS addresses that you're using, and then WAN latency, as well as application tests. Now here's the application test. These are customizable. You can decide to not test applications. You can test productivity apps, right? Salesforce, Box, etc., Zendesk, social if you care to, Facebook, Twitter, etc., LinkedIn, communications, go to meetings. Like this is an older test, so this is not all possible. And then customize too. You can put whatever URLs or IP addresses you want to test.
ClearToSend.net. That's the one I test.
Which one?
I say ClearToSend.net. That's the URL for the website.
And then also over the air. So Wi-Fi throughput test, UDP up, down, it's a TCP up, down. And then also, you don't see it here, but you can do WAN throughput test. So we'll go out and do a throughput test to across the WAN. And so if any of these tests fail, right, you get the if it completely fails, you get a red. If it partially fails, like if one of these apps were to fail, you'd get an orange. And that's where we could have alerts then sent to the person responsible for that part of the network, so they could get out in front and say, hey, we're aware, like say for Salesforce, we know Salesforce is unavailable, so we're working on it, and we'll get back to you shortly. And so that's part of the active network assurance. I say active network assurance because the passive part of the network assurance is out of these dashboards.
Yeah,
we're not injecting traffic, right? We're just
but you got to wait for clients.
Yeah,
you have to wait for clients to come in and then get tickets. Whereas this part of the active network assurance is you proactively testing it before the users come in.
Or if you have someone complaining about, or users complaining about voice in a particular part of the network at a certain time of the day, you can then run simulated VoIP tests for that area at that time of day, so you can do some trend analysis. Now, it's not the same as a Vocera badge or an AskCount phone or whatever, but it's another data point.
Yeah, it's useful for, especially if you're not in that location, so you could run a test without having to fly out there.
And speaking of not being in the location, right, where you want to maybe do a packet capture. So automatically packet captures happen on every connectivity failure, right? Actually, a packet capture happens on every connection attempt, but the successful connect attempts those captures get thrown out. It's only the failed capture attempts that we save, strip the payload and encrypt and put in the cloud. But if you wanted to do a capture, you have a choice of doing a packet capture on any of the radios. You can do it on the 2.4 gig radio, the 5 gig radio, the 6 gig radio, or the multifunction radio. If you do it on the multifunction radio, let's see, I'll say troubleshoot. I'm going to do capture packet trace. You can then, if you do based on the multifunction radio, you can do any channel that you want. So it's like having a discrete. If you select, the default is where packet capture, it's going to capture packets on a channel. And then that would mean that you're going to use that multifunction radio to capture, all the channels in 5 gig, or you don't see 6 gig yet, but you will soon, or 2.4 on a particular channel. You can do 5 gig, for instance. You can do a select channel. Say you just want to capture everything on channel, let's say whatever, I'll say 100, channel 100, and you select the channel width. You can also do a packet capture on the wired interface if you want, and you have your filters. Right? And
could you do both at the same time?
Yes, you can do both at the same time.
Oh, that's good. Okay.
Yeah. Or you can capture the packets. Now this, by the way, when you do the packet capture on the multifunction radio, all that traffic is going to be encrypted. It's going to be at the, so you're not going to see the IP addresses, etc., assuming that the SSID you're capturing, is encrypted. But if you want to capture the traffic in line where you will get beyond the encryption, you'll be able to see, then you can do the BSSID, capture the BSSID. So now that's an inline capture. It's using the access radio to do the packet capture.
Do you lose the layer 2 information?
Yeah.
Okay. So
Yeah.
if you want the layer 2 information, then you do the all pcap on the channel.
Yeah, that's right.
Okay.
Yeah. If you say you want to see the tagging, the WM tagging over the air, etc.
Yeah, I was thinking about like, you know, the 802.11 header, and
Right.
I'm guessing it's like the monitor mode, I guess.
Right. It's like having, I think, it's like having a discrete packet capture tool in the area when I use the multifunction radio.
Yeah, so you want to use all packets then.
Yeah.
Could you do it like on multiple access points if you were studying like roaming?
Yeah.
But then you want to use the multi radio to automatically detect which channel is used by the APs. You see what I mean? Like, I have some sort of automatic to
yeah. So I can't talk. I don't want to talk about the futures too much, but it's definitely something that we've been working on. Yeah, multi AP packet capture for roaming, for specifically.
And so,
issues.
so if we wanted to do, because I'm thinking of ways to do 6 gigahertz packet captures right now. We could use a 360 to do 6 gigahertz packet captures, right?
Yes, that's right. Yep.
Okay. And they would be 4x4 by 4.
That's right. Yep. Yeah. Well, it depends. If it's in line, like on the BSSID that's on the 6 gig radio, then it's 4x4. But if it's the multifunction radio is 2x2. The tri-band. 2x4.
Okay, so it's 2x2. Okay.
2x2. Yep.
Okay.
And now, if you try to doing troubleshooting roaming issues, we have another feature called Live Client Debug. And the Live Client Debug basically is a way to go back to monitor and clients. Say Mateo's laptop. Mateo's been having trouble with roaming. I can go to Live Client Debug. It's not a real client, so not going to be very exciting, but I just start Live Client Debug. And now we're going to look at the conversations between Mateo's laptop and any AP in real time.
And is that a packet capture or?
Actually, it's going to log it to the screen real time.
Oh, okay.
So you would see everything, the four-way handshake, etc. Or if it goes up to Radius, going up to the Radius server, etc.
Oh, so like client events.
Yep. Right.
Okay.
And now, if this were a real client, I could deauth it from here.
Yeah.
And then you could see it re-authenticate, but it's not a real. I could disconnect it here, but it's not a real client. So
I've just tested it with my laptop, so I can see. I connected to the SSID. I can see the BSSID, the AP name, the channel.
Right.
And then I have a whole bunch of logs.
That's right. Yeah. So that's helpful there.
So you could follow like roaming and stuff like this, right?
That's right. Yeah. Specifically, we recommend.
So would you see RSSI as well?
No, I see IP addresses. I see the VLAN.
You want me to stop sharing? Because you can share if you want.
Oh, I guess I see it says 50 dB. Yes, I can try to share. I just have to change the resolution of my screen.
Weren't prepared to share, huh, Francois?
Yeah, no. Well, I mean, Rob, but let me see. So I have it here. Full screen, zoom. Yeah, so it does say something about 50 dB. So maybe that's the SNR, I'm guessing. Can you see my screen?
Yes.
Yeah. Okay.
Right.
So here it says AP received the authentication request at minus 50 dB. So, but minus 50, I don't know, dBm maybe?
Yeah, right. Yeah. Absolutely.
Yeah, maybe it's dBm. So that's the RSSI that the AP sees the clients at.
Yeah.
And then you can see authentication, you can see reassociation.
So that's useful for a live view.
Yeah. You have the four-way. So it looks like they're taking, it's like a more readable version of the packets.
Yeah.
You see the four-way handshake, then you see DHCP.
Yeah. You even see what VLAN they land on. That's cool. I like that. Because then you could test your roaming here and see like at what RSSI it roams.
So if I turn my Wi-Fi off and then on again, we'll see what happens. Maybe it's still live. I don't know. Oh yeah, here, look at that. Disassociation node left, and maybe it will come back. I need to connect to the network.
Yeah, it shows you're on channel 40. Oh, there it goes.
So
There's the BSS ID. Now you're on channel 11.
yeah, I came back on 2.4. Huh? Look
Yeah.
at that.
Hmm.
Yeah, interesting.
And 58 instead of 50, 46, I think 46, 58, 41. Yes.
Oh, your 2.4 is louder.
Probably, yeah, the AP is right. Probably, yeah.
But that's a nice view. I think that's a good way to do like live troubleshooting, have the user try to replicate the issue, do the roaming. You could see what AP they're really joining to.
And you can download it, so
You're right.
you could do some more analysis. Awesome. Okay. I
Okay,
can let
cool.
you take over.
Well, I mean, we covered a lot in this episode, right? And we do plan to have a couple more episodes where we dive a little bit more into network assurance, and then we'll also dive into WIPs as well, because I don't think security is really talked as much with Wi-Fi other than, enabling PSK or 802.1x. Like, what else is there with security that we can do over wireless? But Robert, is there anything else you want to add before we close? Like, maybe we should talk about where people could find some more resources and learn more.
Right. Yeah. And so as far as resources, we do have some links that can I share in the chat here? And so people.
Well, we can add them to the show notes. So
Okay,
I mean, if people go to cleartosend.net/276, we can add a couple links to some resources that's worth checking out. Maybe you can talk about briefly what those resources are.
Yeah, sure. We have from our website, we have a Cognitive Campus page, and there's a white paper, Cognitive Campus white paper there, and then an overview of the Cognitive Wi-Fi solution. And there's also this third-party report that came out about a month or two ago, a group called ESG, where they basically think of it like a third-party competitive test report, but no competitors. So they put us through the same, a bunch of test scenarios, right, to validate our claims, marketing claims. They've looked at both the wired side and the wireless side, as well as the NDR or Wake solution. So it's more comprehensive than what we covered today, but that ESG tech review is available for download as well from our website.
Awesome. Cool. So we'll include a link to those resources over at cleartosend.net/276. For those of you on the audio, you could also go to those show notes to look at the video and see the screen sharing that Robert was doing, looking at the interface and the platform of what's capable of Arista Wi-Fi. Anything else to add before we close, guys?
I'm good. I still have questions, but I'm keeping them for the next episode.
Okay. Yeah. So the next one we'll do network assurance, which I find will be interesting because for me, like making sure Wi-Fi is working before people have issues is kind of where we want to be, right? To test it out. And we kind of went into that a little bit, Robert. You showed some of that with the testing, but we'll go into that in more detail.
Right.
All right.
That sounds good.
Cool. Well, Robert, Metka, thank you, both of you, for joining us on this episode. If anyone has any questions, be sure to hit up the show notes and we'll monitor any comments there if you have questions. And if there's something that me or Francois can't answer, we'll forward them over to Robert and he can provide some answers. But we want to thank you guys for watching or listening to this episode, and we hope you found it valuable. Thank you, guys.
Thank you, guys. Bye-bye.
Thank you. Thank you.
I know.